Alright, the lesson we're going to look at today is factoring trinomials and factoring with special products. And first we're going to look at factoring trinomials, which is pretty important to the course because we're going to use it pretty much from here out. We're going to be doing a lot of factoring basically in every chapter that we cover. So this is a pretty important topic to understand. So you remember us talking about trinomials already. It's a polynomial that has three terms, and it's going to be in the form ax squared plus bx plus c. And the first problems we're going to look at, the lead coefficient a is going to be a 1. So first you want to make sure that your three terms are in descending order by exponent, and then check to make sure if there is a GCF other than 1 among those three terms, that you factor out the GCF first. And then there are a couple of different methods that we can use to factor these trinomials, but the first ones that we're going to look at for the case when a is equal to 1, we are going to kind of look at the trial and error first, because when a is 1, that's the simpler case, and trial and error is a little more straightforward. So if we look at the first problem, x squared plus 5x plus 4, if I write the standard form of the trinomial over that, ax squared plus bx plus c, you can see that a is indeed 1 in this problem. So to use trial and error for problems where a is equal to 1, the first thing that we want to do is determine what c is. So if you look at the form again, c in this case is equal to 4. So once we know what c is, we're going to find and list the factors of whatever c is, which in this case is 4. And then once we have that list of factors, we want to determine which pair will also add together to give me b. So first, now that we know that c is 4, let's list out the factors of 4. And remember, factors are just two things that multiply to give us 4. So the first one I think of is 1 times 4 would be 4. The next one is 2 times 2. Now if we wanted positive 4, we could also say negative 1 times negative 4, or negative 2 times negative 2. But remember, our next step is going to be to look and see which pair of those factors will add to b. And in this particular case, b is 5. And since that is a positive number, negative 1 and negative 4 won't add to a positive, and neither will a negative 2 and a negative 2. So we really don't have to consider those two cases. So if I look at the first set of factors, 1 plus 4, that does give me 5. And of course 2 plus 2 is going to give me 4. So the factors that I need are going to be 1 and 4. So the original problem is x squared plus 5x plus 4. Anytime I'm factoring a trinomial, it's going to factor into a binomial times a binomial. How do I know that? If you relate that back to the multiplication problems that we looked at, you remember when it was a binomial times a binomial, we said that we could use the FOIL method, we could distribute, or we could use the box method. But any of those three methods that you used, If we multiplied one binomial times another, we got a trinomial. And factoring and multiplying are opposites of each other. So if I have a trinomial, it's going to factor into two binomials being multiplied. The reason that the case where a is 1 is simpler than other cases is I know what goes into these two first spots is going to have to multiply to give me x squared. Well, what makes that easier is there aren't multiple things that I can multiply and get x squared. The only thing I can multiply is x times x to get x squared. And then to finish the binomials off, that's where the factors that we just found came in. We said that the factors that multiply to 4 and add to 5 were 1 and 4. So that means my binomials are going to be x plus 1, x plus 4. So x plus 1 times x plus 4 is the factorization. You can always check to see if you have the correct factorization using the information that we talked about factoring and multiplying being opposites. If x plus 1 times x plus 4 is the correct factorization, then if I multiply those two binomials, I should get the original problem back. If not, we've done something wrong and we need to try over. So remember, if I'm going to multiply those two binomials, we can use FOIL, we can use distribute, we can use the box. Just for time's sake, I'm going to FOIL. So if I multiply the first times the first, x times x is x squared. If I multiply the outside, x times 4 is 4x. The inside, 1 times x is 1x. And the last, 1 times 4 is 4. And if I collect those like terms, you see I am going to get x squared plus 5x plus 4, which is indeed the original problem. So I know that x plus 1, x plus 4 is the correct factorization. Alright, so let's look at the second problem. Again, our a is equal to 1. So we're going to start by identifying what c is. In this case, it is negative 45. So we want to find the factors of negative 45. So I can multiply 1 times negative 45. This time I also have to consider negative 1 times positive 45. To find more factors, you can use the calculator if you need to. Just start dividing 45 by larger and larger numbers. We've done 1. If you go to 2, if you put 45 divided by 2, you're going to see that that's not evenly divisible. So the next one we would try is 3. If you put in 45 divided by 3, you'll see that that is even. So I would get 3 times negative 15 as a possibility. Or, of course, we could also have negative 3 times positive 15. 4 will not divide into 45 evenly. 5 will. So we would get 5 times negative 9, or negative 5 times positive 9. And if you kept going, you would find that the factors would start to repeat. So if you kept going, like the next one that you're going to get to would give you 9 times negative 5, which is a repetitive set of factors. So we don't need to keep listing any further. So now what we need to do is see which set of those factors we just found will add to negative 4, which is the B. And of course, you can go through and write each one of these out if you want. A lot of them you're going to be able to see from looking at them that they're not going to work, right? The first one, 1 and negative 45, when I add, that's not going to be negative 4. Negative 1 plus 45 is also not going to be negative 4. If I come down to 3 plus negative 15, that's not going to be negative 4. Negative 3 plus 15 is not negative 4. But once I finally get down to 5 plus negative 9, that is the set of factors that will add to negative 4. So if I go back to my original problem again, a squared minus 4a minus 45, we know that it's going to factor into two binomials. My two lead terms, the only thing that will multiply to a squared is a times a. And we just determined that the factors we need are positive 5 and negative 9. So we're going to get a plus 5, a minus 9. Now you can multiply that back out and verify for yourself that that factorization does give you the original problem back. Also, I want you to notice that if we wrote the two binomials in the opposite order, those two things are exactly equivalent, so either answer is perfectly fine. The only thing you can't do is start mixing the signs up. A plus 5 times a minus 9 is not equivalent to a minus 5, a plus 9. If you multiplied that back out, you would not get negative 4 in the middle. So that was not a correct factorization, but either of those is perfectly fine. All right, if we look at the third problem, the first thing you might notice is we've been looking at problems where a was 1, and for this one, a doesn't look like it's 1 this time, right? It looks like it's 3. But if you look at the entire problem, you'll see that all of the numbers in that trinomial are divisible by 3. So we have a GCF this time. So this is where we have to be careful. If there's a GCF, we need to factor that out first. So the first thing I'm going to do with this one is factor out that GCF of 3. That's going to leave me with x squared plus 11x plus 30. And now the polynomial or trinomial that's left in the parenthesis does have an a equal to 1. So now we can use the same method we've been using. So in this case now, my c is going to be 30. So if I start listing factors, I have 1 times 30, 2 times 15, 3 times 10. 30 is not evenly divisible by 4. We get 5 times 6. And I think after that they would start repeating again. So now we can switch to seeing which one of those pairs will give me b equals 11. So again, you don't have to write out all the combinations if you don't want to. If you look at the 1 and the 30, we know that 1 plus 30 is not going to be 11. 2 plus 15 is not going to be 11. 3 plus 10 is not going to be 11. The only one that works is the 5 plus 6 does give me 11. So those are going to be my factors. Now, I'm going to go back to the original problem, 3x squared plus 33x plus 90, like we've been doing, because we can't forget that the first thing we did was to factor out that GCF that got us to here. Now we can write for our two binomials to get the x squared. I know both of my first terms will have to be x, and we determined that our factors are positive 5 and positive 6. So we'll get x plus 5, x plus 6. So this entire product is our factorization, 3 times x plus 5 times x plus 6.